Hello, we're going to take you through the millet data and just work through what this data set is and the kind of story behind it. So this is a simulation and it's on the yield of millet. It's a large scale on farm experimentation. So we have lots of different farms and we've got lots of different experiments going on to see what factors affect the yield of millet. So the data set has 10 variables. Every row in the data set is going to be the yield of millet for a specific plot in a specific year. So those certain factor levels that are given in that row. And when I say factors, I mean treatments. So there are 3 treatments, each of which having 2 levels: variety, xy, and weeding type or décephage. So here are 3 treatments. This is what your kind of data set may look like. And there's your 3 treatments: variety, xy, and décephage. So let's just look through what these are. So variety, we have 2 types of variety. We have ICRI and local. So what we want to see here is, I guess, does the variety affect the yield of millet? Or maybe that's what you want to see. Or do you want to see, you might be asked another question. It might be, okay, which variety would you recommend in this situation? But I won't give too much away. Then there's 2 types of xy. There's yes and there's no. So this is taken, this simulation is in West Kenya, where my colleagues do a lot of work, and that's where this has originated from. But xy, this is kind of what xy is. It's a picture. I had no idea what it was before this simulation, but it's a farming technique where you dig pits in the soil to catch water and concrete compost. So it's used in Burkina, Niger, Mali, just over in Western Africa in farming. And there's a little video there if you just wanted a little bit more information on it. And then there's 2 types of weeding. We have normal weeding or a specific type of weeding, which might be kind of like weeding around the plants type thing. And there are 3 treatments. We have a few other variables in the data set, which are all factors, and these are structural. So we have the year, and so the trials repeated over 2 years, 2017 and 2018. We have gender, so the man and the woman. We have region, so this is done in specific communities within 3 regions. So we have Enigrab, Elam, and Reagan. We have soil, so all regions have a kind of broad categorization of their soil, and so within the communities, within our different regions, both soil types are used. And then we have plots. So each farm has 6 plots. And the real idea behind it is it's a simulation. So the idea is there shouldn't be this should be simple, as it were. This should be, everything here should be explainable. Everything should be accountable apart from your natural variability. This is to say, all your variability should be identifiable. We shouldn't have any of this ugly, unidentifiable variability in here because it's a simulation. And so we'll see how you get on. We'll see how it goes. But this is it, and it should be be relatively straightforward. But hopefully you'll find, because I know I certainly did, as have everyone else who was given this to, it's a lot more challenging than you might expect. And it kind of makes you think, well, if it's this challenging on a simulated data set, then wow, real life is a bit different. At least that's what I took away from it when I was given this game. But yes. Oh, and then of course the final variable is our yield, rendement, which is the yield of millet. There's our yield there in the data, and here's the other variables.